Good day, everyone, and hopefully everyone's having a great day to this point. We're going to be starting off Unit 4 by talking with trig identities, okay? So this is going to be the first lesson that we actually deal with within Unit 4, okay? One of the big things that you're going to have to understand within Unit 4 is a lot of what we do is just simplifying. It's just how we look at it is a little bit different, okay? We're going to simplify using our trig identities. And what these are a set of different formulas, equations, things like that we have used to help simplify drawn out long trig equations to get down to a point that it is a lot simpler, okay? But to do this, we also have to look at the true concept of an identity. Like, what is an identity and how does it work? Well, identities are actually all over algebra. And kind of weirdly enough, you've been dealing with identities kind of your whole math career. Okay. For example, if you look at letter A here, notice how we were to basically get 2 times x plus 3 and 2x plus 6. Well, if you were to distribute that 2 throughout that parentheses there, you would get 2x plus 6, which is the same as what we have on the other side. Notice how we wrote basically the same exact answer two different ways. Okay? 2 times x plus 3 is an identity of 2x plus 6. Same thing with letter B. If I look at letter B, we have 2 on top, 2x plus 4 on bottom, and we have 1 equals x plus 2 on bottom for the other side. Well, if I were to factor out a 2 on bottom here, if I were to factor out a 2 on bottom to get 2 over 2 x plus 2 and cancel out top and bottom, that will leave me with 1 over x plus 2, which is the same as what I have on the right side. Okay. See how, once again, those are identities of one another. So an identity is just basically a simplified version or another way to write that particular answer. Okay. So first and foremost, understand that key concept. Okay. The next thing I want you to understand is that sometimes you don't always have an identity. For example, if I look at this value here compared to x plus 1 times x minus 1, if I were to actually FOIL this out, I would get x squared minus 1. So notice how these two values aren't necessarily identities of each other, because when I actually FOIL those out, I don't get that as an answer. So we still have to be able to check and see if our identities actually relate to one another. Okay. Eventually, this leads us down to letter D, which is going to be one of the key things that we actually discuss. Secant and cosine. Well, we talked about how cosine of theta is equal to our x coordinates on our unit circle versus a secant of theta, which is equal to 1 over x, which is the reciprocal of that value. Well, what we're going to start deriving, or what we're going to start getting into, is that we can actually use identities of secant and cosine to our advantage, kind of like what they do right here. This same concept of cosine of theta equals 1 over secant of theta is the same thing that's resembled down here. We just wrote it as a trigonomic identity. For example, if I flip these two values, I would get cosine, okay? Or cosine of theta is equal to 1 over secant, okay? So once again, that's kind of one of the things that we want to discuss and we want to be able to derive out of this, is that we want to be able to build our identities of our trigonomic functions. To do this, the first thing we have to understand is, in a unit circle, what do each of our functions represent? Well, the three that are the most common, the three that we're used to the most, are sine, cosine, and tangent. Sine is y, cosine is x, tangent is y over x. Well, the thing you have to understand is cosecant, secant, and cotangent are just the reciprocals of those three functions. Cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. Okay? Well, the reason that's important is because when we actually look at our reciprocal trigonomic identities, this same concept of these two really just being flipped fractions of one another is going to play into how we actually express our trig functions. Okay? Eventually, that leads us into what are our trigonomic identities, and understand that they are just reciprocals of one another. For example, another way or an identity of sine of theta is going to be 1 over cosecant of theta. Same with cosecant, our identity of that is 1 over sine of theta. Cosine's the same way. Our identity to that is 1 over secant. And identity of secant is 1 over cosine. Last but not least, tangent, and I'm going to write these in a different color because these can have two different ways to write it, is either 1 over cotangent of theta, or it could be, not cosine, excuse me. Let me rewrite this one. Tangent could be 1 over cotangent of theta, or it could be sine over cosine. Versus cotangent, which could be 1 over tangent of theta, or the reciprocal of that, which could be cosine over sine. Okay? So we have all these different reciprocal identities that we can use to our advantage, okay? These reciprocal identities can help us basically derive out how we can actually simplify and solve for a bunch of different examples in a problem, okay? Now, eventually, we are going to be talking about how we can actually simplify equations, okay? In 21-2, in your next lesson, we're actually going to go through examples of how we can use these to help simplify. However, for today, it's just kind of seeing them and understanding them and going through them, okay? The next portion of this lesson is talking about our Pythagorean identities, okay? Well, interestingly enough, we are actually able to use the Pythagorean theorem to actually help us derive a specific identity for this problem, okay? A Pythagorean identity is going to follow the form of a squared plus b squared equals c squared. However, we want to basically import trig functions into that. Well, one of the interesting things we notice is that if I actually solved out for all these different angle measures right here, if I were to take cosine squared and sine squared and actually combine them together, one interesting thing would always happen. For example, if I did cosine squared of 60 degrees, I would get 1 over 4. If I did sine squared of 60 degrees, I would get 3 over 4. Well, if I were to add those together, 1/4 plus 3/4 would be 1. If I go to 225 degrees, cosine squared would be 1/2, sine squared would be 1/2. Add those together, that would give me an answer of 1. Negative 90, cosine squared would be 0, sine would be 1. Add those together, my answer would be 1. So one of the things that we notice within math is no matter what angle we did, if I were to do cosine squared plus sine squared, my answer would always come out to be an answer of 1. So what we did is we created an identity out of that. We did cosine squared of theta plus sine squared of theta comes out to be 1. Now, a lot of people are wondering, like, how do we relate that back to the Pythagorean theorem? Well, we really just want to understand the unit circle and how we can actually use this, okay? Well, how do we actually relate this back? Well, the original Pythagorean theorem is a squared plus b squared equals c squared, right? Where we have a, b, and c, c being our hypotenuse, okay? Well, what if I just changed the actual lettering of this, okay? What if I change a to be x, because that's technically our x coordinates, b to be y, because those are our y coordinates. Instead of c, because our hypotenuse equals 1, we change c to be 1. Well, this would become x squared plus y squared equals 1, right? Well, the last step I could do, and once again, this is kind of just proving why we call it a Pythagorean identity, is that if I just continue this process and I replace x and y with cosine because cosine equals x and sine because sine equals y, I would get cosine squared of theta plus sine squared of theta equals 1. So notice how I can progress through using the idea of what each value equals. I can plug in an x for the a because that is technically my x value, and I can plug in cosine for x because cosine equals whatever our x value is. So I can eventually derive this equation right here, which is once again going to be helpful in understanding identities and moving forward. Okay? Now, understand there's a lot of different forms that this can take on. For example, if I look at this particular example, notice how I start off with my Pythagorean identity, but they're saying, oops, what if I were to divide by cosine squared? Well, notice if I were to divide by cosine squared, this would cancel out and become 1. Sine squared over cosine squared would come out to be tangent squared. Because once again, if you think about sine squared over cosine squared, that's our identity, right? See how that works? Okay. So I can change sine squared over cosine squared into tangent squared. And then last but not least, if we look over here, notice how 1 divided by cosine squared becomes secant squared. Because once again, that's our identity of 1 over cosine is equal to secant. So all I got to do is just add a squared value to that. So if you notice, by dividing out certain values within this equation, I've created a new Pythagorean identity. Okay? Same thing could be done with a sine squared function. If I divide by sine squared, this would be sine squared divided by sine squared plus cosine squared divided by sine squared equals 1 over sine squared. Well, how does that simplify? Well, sine squared over sine squared is going to cancel and become 1. Cosine squared over sine squared, we go back to our reciprocals. If you notice, cosine over sine is a cotangent. So this becomes cotangent squared of theta equals, and then 1 over sine squared, we just go back to our identities and say, okay, 1 over sine squared's right here, that's the same as cosecant. So I can replace this with cosecant squared of theta. Okay? Giving us our third Pythagorean identity sitting right there. 1 plus cotangent squared equals cosecant squared. Okay? Now, overall in this lesson, we're really just presenting these all for you. Okay? All of these different identities are going to be used in the long run to solve out larger problems. A lot of it dealing with verifying. Okay? So in today's lesson, the key thing we want to understand is, what do all of our reciprocals equal? Well, sine is 1 over cosecant. Cosecant is 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. Tangent and cotangent have 2 different values. You could either go 1 over cotangent and 1 over tangent, or you could do sine over cosine and cosine over sine. Okay? This grouping right here are reciprocal identities. Okay? And then down here with our Pythagorean identities, we have 3 total. We have sine squared of theta plus cosine squared of theta equals 1. We have tangent squared of theta plus 1 equals secant squared of theta. And our last one is we have 1 plus cotangent squared of theta equals cosecant squared of theta. Okay? These here are 3 Pythagorean identities. All right, Pythag identities. Okay? Now, like I mentioned, today's key process, the big thing we're doing today is understanding how we could actually write all these values out. Okay, that is like the number one thing that we are focused on in today's lesson. Moving forward, just kind of show you this. If I just focus on other examples or things like that, or just kind of show you what we're going to be actually doing with these, a lot of it kind of resembles what we're going to be talking about in the next lesson in dealing with things like how do we actually verify value. So if you notice, this is kind of one of the examples we're going to look at in the next lesson. If you look at sine, cotangent, and secant all being multiplied together, we want to be able to simplify those values out. Well, I can change sine into sine over 1, cotangent into cosine over sine, and secant to 1 over cosine. And if you notice, they're able to cancel out things like the cosine on top, the cosine on bottom. Those would cancel. And we're able to cancel out things like the sine on top and the sine on bottom here. Notice how we were able to cancel all those out to get an answer of 1. And we do this by using all of our identities, okay? So that's going to be the process that we focus on and then we use at a later point. Today's lesson is strictly kind of presenting these for you to see. In the next lesson, we're actually going to apply them and try to cancel things out, okay? Besides that, we'll finish this off in class tomorrow. We'll be going over everything dealing with these examples. We'll kind of start talking about how we actually use identities. Besides that, have a great day, and I'll see you in class.